So this is activity 3, the music of optimization. In this activity, what we want to do is use our problem-solving skills to solve a problem involving optimization, and then our ingenuity to bring it to life to actually construct the optimal model. And so down here we have 5 different parts again: the conductor, Ludwig, Amadeus, Johann, and the singer. And so we follow the different parts of the symphony, hence the name music of optimization. So in the first part, we have the problem, and so the problem stated. And so it's a simple problem. What you have is you have a piece of paper that has a perimeter of 24 inches, and from that piece of paper we want to construct a rectangular tube. And so the idea is that we make these 3 folds here, and we fold it together, and we get this rectangular tube. And so what happens in this first part is that we see that there are lots of different pieces of paper that have a perimeter of 24 inches. All right, so we could have a skinny piece of paper like we do here, right? Or we could have a perfectly square piece of paper here. They both have a perimeter of 24 inches, and so they give us different rectangular tubes, and we'll see in a minute that they have different volumes. All right, so here it says give another example. And so there are lots of examples. I made one. Let's go back and change that. So I made one that had a rectangular shape like this, and one side was 2 inches, and then this side was 2 inches. And then this side here, then of course, was 10 inches. Right, the idea is that if you add up all the sides, the perimeter has to add to 24 inches, because that's what's given to you. So 2 plus 10 plus 2 plus 10 is 24. And so then over here, I want to fill this in. So Johann says, fascinating, I know a little bit about computing volumes. So let me think. The volume is equal to the length, the width, and then of course times the height. And so in the first one, we compute the first volume, right? So if you go back to the first page, what they did is they took here the length, which actually turns out to be a fourth, right? Because 1 divided by 4, times the width, which is also going to be a fourth, right? So this will be a fourth, that'll be a fourth, and the height will be 11. And so over here, it's 1/4 times 1/4 times 11. In the second picture, the second one has a volume of 6/4, 6/4. Right, so if you look in the second picture, we have the length of this little piece is 6/4, right, times another 6/4. Right, so you have 6/4 here, times 6/4 here, times the height. Okay, and the height is the same thing as this 6. So you have 6/4 times 6/4 times 6. Right, so you put 6/4 times 6/4 times 6, and you get out 13.5 inches cubed. So you can do this on your calculator. So my calculator here, you can do 6 divided by 4 times 6 divided by 4 times 13.5. Then you get out oops, I messed that up, right? So that 13.5, that should have been a 6. Right, so there we have 13.5 inches cubed. And the last example, this is the one the group constructed. So we go back and we look at the one that we constructed, and we realize, now there are going to be these dotted lines where we make these folds. Right, so 2, 3. And so this length over here is 10/4, right? And then 10/4. These are all 10/4. You divide 10 up into 4 pieces. And we see when we construct our box over here, when we construct our rectangular tube, right, what we have is 10/4, 10/4, and then 2 inches here. And so the volume is 10/4 times 10/4 times the height, which is 2. And again, on my calculator, I can do this. So 10 divided by 4 times 10 divided by 4 and times a 2, and I get out 12.5 inches cubed. Okay. And the whole point of this is to show you that there are lots of different rectangular pieces of paper that have 24 inches for the perimeter, but their volumes are all different. So up here, the volume was 0.69 inches cubed. Right here, I had significantly larger, 13.5 inches cubed, and this one was just slightly smaller, 12.5 inches cubed. So they have different volumes. And what we want to pay attention to here is that Amadeus makes this connection. He says, "Oh, amazing, it's like my music. There are an infinite number of sequence of notes, but there's just one perfect sequence for each piece I compose." Right, so the same idea generalizes to this problem in optimization. There are an infinite number of rectangles that have a perimeter of 24 inches, but there's going to turn out to be just one that gives the largest, and so we want to go find this optimal piece of paper. All right, so in the next part, the Adagio, we're going to make the picture, and so here we start. It says we start with the picture below. I know the perimeter is 24 inches. Right, now I'm trying to find the maximum, remember, volume. You can go back to the original problem. It's volume. So I'll put find the maximum volume in the empty box below. So we want to write this all down. So this is 24 inches. And I want to find max volume. All right, so then we come down here. The Singer tells us to use X and Y. So there are two ways of actually solving this problem. So instead of labeling the tube, what we can do is we can label the rectangle on the left. We can label the length X and the width Y. And so the length would be X, while the width would be Y. This means the length of the tube, and so now here's where students typically struggle. All right, the tube, right, this length here corresponds to, well, let's do it down here, this length down here, which is not X, right? It's actually X divided by 4. And the same thing here, right, because that's this length here. So that's also X over 4, and then the height is Y. So this means the length of the tube is X over 4, the width of the tube is X over 4, since the basis is square, and the height is Y. And the Singer tries to help you. Does everybody know why we divided by 4? The reason we divide by 4 is because we're dividing X up into 4 parts here, 4 pieces. On the next page, we're looking for a formula for the volume. And so we know the volume is the length times the width times the height. If you look back here at the picture, the length is X over 4, the width is X over 4, so this is X over 4. And then the height is my Y. Okay, and we keep on going, and so then here it says, what, really, Amadeus, you cannot graph this because there are, well, you can't graph this. The idea is you'd love to graph this and then look for the maximum, but you can't graph it because you don't have one letter, you have 2. Right, so we need it to have one letter only because we can only graph functions of one variable on our calculator. And now we walk through this. We're going to talk about how we get rid of one letter. So it says the perimeter is 2L times 2W. All right, so here we have our perimeter, which remember our perimeter was 24 inches. And we used X and Y instead of W, L and W. So we have 2X plus 2W. When you solve this for Y, so move over the 2X. So I get 24 minus 2X. And then divide both sides by 2. And so I get 12 here, and then minus an X there. So I get Y equals 12 minus X. And so therefore I have V equal to X over 4 times X over 4 times a 12 minus X. Right, now I have V as a function of one variable, so I should be able to graph it. So the fourth part here, we're going to solve. Right, so we're going to graph this thing. And so I got, here it says the input is X, which is the length stuff. So you should use X min to be 0. Right, and X max to be, remember the perimeter is 24, so if you want, you can put 24 here, but if you look at the picture, I already labeled it for you, you go to 12. Right, the idea is that, remember, X and Y, this is the length, X is the length of my rectangle, Y is the width. Right, if the perimeter is 24, then X can be no bigger than 12 because you have another X down here, so 12 plus 12 is 24, so this will give you a nice looking window. After all, the length cannot be longer than half the perimeter of the rectangle, which is, we have 24 inches for the perimeter of the rectangle. All right, so now when I graph this, I come over here, hit y equals, and I'm going to graph my volume equation, so x, divided by 4, times x divided by 4, left parenthesis, all right, if you want, you can hit times again, times left parenthesis x minus 12, in parenthesis, go to your window, 0 to 12, go to zoom fit, and since it's a maximum, it should come up and then come down. Oh, something's wrong, right? Because it's going down and coming up. So I hit y equals, and let's see what did I do? What did I put in there that was wrong? Oh, it's 12 minus x. So I should go back and look at the formula. It's actually 12 minus x. So when I come over here, it's not x minus 12. It's 12 minus x. Okay. And I knew it was wrong because it went down and came up, and so that would be giving me a minimum, and I want it to be a maximum. So it's actually 12 minus x. Let's do zoom fit again. So there it is. It comes up, and it goes down. Perfect. So it goes up and comes down like that. All right. And so now I want to find the actual maximum. So to do that on my calculator, I hit second trace, and I'm going to hit maximum. All right, and it's going to say left bound, so I look at my cursor, and yeah, it's to the left of the maximum, so I hit enter. And I can scroll to the right, so I just keep going to the right. It goes up, and now it's going past the maximum, so then I'll hit enter again, give it a guess, hit enter, and out pops my answer. So it says my input is 8, and my output is 16. So now remember, my output is actually V, so my volume is 16 inches squared, while x is my input, which is 8 inches. And then now I have to find y. Now remember that this y and this y are not the same thing, right? This is actually the volume. So to find y, I have to go back and remember that y is equal to 12 minus x. So this will be equal to 12 minus 8, which is 4. When the singer tries to help you here, he says, do you know why y is 4? All right, so the song is over, right? Up come the lights, and now it's time for the performance art part. So here we're going to test, and so what you want to do is we take out this piece of construction paper, a ruler, and 4 stickers. So down here, and fill these in, right? So x was 8 inches, and y was 4 inches. And so here's my paper down here. Now remember, x is the horizontal and y is the vertical. So what I want to do with my piece of paper is I want to take my ruler and I want to measure off horizontally 8 inches. So here's my ruler, so I want to measure off 8 inches there. And then vertically, I want to take off 4 inches. So I guess probably what I would do to do this, I'd probably take this and I'd measure off 8 inches up here. So I take this, here's your 8, and then I can, fold it along this line. So I'd make a fold right here. All right, so I'd make a fold from here down to here, and I'd rip all this off on the right. So I'd rip all this off, so this all gets ripped off. Fold it and rip. And then I would take my ruler, and I'd measure off 4 inches. All right, so I'll come here and measure off 4 inches. So here's 1 inch, 2 inch, 3 inch, and 4 inches on this side. And take it over here and measure off again 4 inches. So here's 1 inch, 2 inch, 3 inch, and here's 4 inch on this side. And then I would take this and fold it along here. And so now all this will be gone. So that's all gone. So all I have is the stuff left in the middle. So I take this piece of paper right here, and then I would fold it probably first down the middle. All right, so it's easy to fold down the middle. I just take this end and I bend it over to that end, and I'll get a fold that's right down the middle. I could also take my ruler, of course, and figure out, where the middle occurs, where the 4 inches occur. So I could take my ruler and do it right here, so I get 4 inches, and I could fold it, right down the middle. And I could also then, once I fold it down the middle, it's easy to get the two sides. I can lay it flat and fold this end to that end, right? Or again, I could use my ruler and fold it there, and use my ruler and fold it there. And so once I have all this, I can make these 4 folds, and I can make my tube. And then I use my stickers, right, to put together. Basically, I stick them, here, and I attach them over to this side. Okay, and I get my rectangular tube. In the end, you want to put this all together. So the final page, it says the musical score, the music of optimization. So put together all we did here so that you can hear the music of optimization. So here's a statement of the problem. A rectangular tube with a square base is made by taking a flat rectangular piece of paper, right, and folding it together in equal parts 3 times. So see the picture. If the perimeter of the flat piece of paper is 24 inches, then determine the largest volume of the tube. All right, so I started the picture off for you. What we did is we labeled this side X and this side Y. And so then when we make 4 folds, we break X into 4 pieces. So we divide X by 4. So we get X over 4 here, because that's the length of this piece. And then X over 4 over here, right, because these are all the same length. And then, of course, height Y. And we want to find the max volume. And I know the perimeter is equal to 24 inches. All right, so now I'm going to look for an equation. What type of equation am I going to look for? A volume equation. So V is equal to, right, it's length times width times height. So in this one, it's just X over 4, right, times X over 4 times Y, right, just like before. And now I have these 2 letters. I wish I only had one, because then I could graph and find the maximum. So to get rid of the Y, I'll use the 24. So 24, which is the perimeter of the rectangle. Remember, this is X and this is Y. So I have 2 X's plus 2 Y's. And I can solve this for Y by moving over the 2X first. So I subtract 2X from both sides. And then I divide both sides by 2. So I get 24 minus 2X, all divided by 2, equals 2Y. Oops, 2Y divided by 2. And so then Y is equal to divide 24 by 2, so that's 12, minus divide the 2 by 2, so I just get an X. And so I have V equal to X over 4, right, times X over 4 times a 12 minus X. So now I want to solve. So again, to solve, I just plug it into my calculator, and I already have it in there. Y equals X over 4 times X over 4 times 12 minus X. I've already made my window, so I just go to my graph, and to solve, I copy down this graph, 0 to 12. It came up, came down. The maximum occurs right here. To find it, I use the maximum button. So I hit second trace, go down to maximum, so number 4. Left bound, I can do this one, just hit 0 for the left bound. Right bound, 12 is certainly to the right. And so hit enter, and give it a guess, just hit enter again, and I get my maximum volume, because it says find max volume, so volume is equal to 16 inches cubed. So that's my final answer. Right, my testing part, you paperclip your model here, and conductor says, now that is music to my ears, bravo, and we're done.